these are some of the other theorems and postulates what we have. Maybe we can try to prove the first theorem, x plus x gives x. So let's try to work out on that. So x plus x should give x. So let me take the left hand side first. So x plus x, this can be written as x plus x into 1 or and 1. We know that anything and 1 is again that anything value. Now what we can do is x plus x, and this 1 can be written as x plus x dash. We know that anything or its complement will always give us 1. Okay. Now this can be again written with the help of the reverse distributive property, like x plus x x dash. So what I mean is, if you try to expand this with the help of distributive property, it's like a plus b dot c, which is given as a plus b dot a plus c. So that's what we have here also. So I have just simplified these two terms in order to bring x plus x x dash. Now moving further, let me erase this part. So x plus x x dash. Now we know that x into x complement will always be 0. So finally we have only x. So that is your right hand side. Hence it is proved. Now we can take another one which is just the opposite. X dot x is equal to x. We'll try to prove that. So x dot x should give us x. So let's take the left hand side first. So that's nothing else but x dot x. Now here this x dot x can be replaced with the help of x dot x plus 1. We know that anything or 1 gives that, anything or 0 gives that anything value. So this 0 can be replaced by x x dash. Okay. So then what we can do, we can take x common here. So x plus x dash is what that is left out. We know that anything with this complement or complement will give us 1. So that is x dot 1, which is nothing else but x. So that is your right hand side. Hence it is proved. So likewise we can have another theorem. So apart from this, we have all the other properties like the associative property what we have spoken before, and then we have the distributive property. Okay. So x dot y plus z is equal to x dot y plus x dot z. And similarly, there is another important theorem called as De Morgan's theorem, which states that x plus y the whole dash is equal to x dash into y dash. So when we are having a whole complement, we can bring that complement inside the bracket, replacing the OR operation into AND operation. And when we have an AND operation, we can replace that with an OR operation like what we have here. So this is another version of De Morgan's theorem, which says that xy the whole complement will give you x complement, and there is an AND operation between x and y that is converted to OR operation y complement. So once we bring the complement inside your bracket, the operation changes and also the complement value changes. Okay. Then we have an absorption law, x plus xy that gives us x. We'll try to prove these things in your future. So first one, let's take a simplification theorem, which states that x plus x dash y gives x plus y. Okay. Maybe let's start from the left hand side, which gives me x plus x dash y. Then let me try to apply the distributive law here. So that gives me x plus x dash into x plus y. So you know that x plus x dash is always 1 dot x plus y. So 1 and anything will give you that anything value, which is x plus y, which is nothing else but your right hand side. So pretty cool, isn't it? Yeah. Then we have another important theorem. We call them as consensus theorem, which states that AB plus A dash C plus BC will give us AB plus A dash C. So let's try to prove this. You can take the left hand side first. So which gives us AB plus A dash C plus BC. So what we can do here is, I can just add a value to this A dash C plus BC plus 1. Okay. And Okay, instead of adding 1, what I can do is I can multiply with this one. Okay, so it's like AB plus A dash C plus BC dot 1. Okay, so this 1 can be replaced by A plus A dash. So what we have here as a result is AB plus A dash C plus BC dot A plus A dash. I can replace this 1 with A plus A dash. Now in turn, what we can do, we can just bring down this one AB plus A dash C plus when we try to multiply these two using a distributive law, that gives us ABC plus A dash BC. So when you have ABC plus A dash BC, what we can do is we can combine these two terms, and internally we can combine these two terms. So when we do that, in these two terms I have AB common, which ultimately gives me 1 plus C, plus if I try to combine the second and the fourth term, I have A dash C common, and I can have 1 plus B. We know that 1 or C is always 1 and 1 or B is always 1, and remaining we have A dash C. Here I have AB. Okay, so ultimately this gives us an answer AB plus A dash C. So hence the theorem is proved. So we can have another version of the consensus theorem, which we called as the dual theorem, or dual of any expression. So dual of any expression is obtained by changing the OR operation to AND operation and vice versa. So let's try to have the dual of consensus theorem. So consensus theorem states that AB plus A dash C plus BC gives us AB plus A dash C. So when you want to try to obtain the dual of this, we have to convert all the OR operations into AND and all the AND operations into OR. So first let me take this A and B. So I will put it as A plus B. Then this OR operation is converted to AND. And then I have A dash C. So I will call it as A dash plus C. Then again I will have an AND operation, which is B plus C. And on my right hand side, A or B and A dash or C. So this is the dual of the consensus theorem. So both the theorems are same. Wherever applicable, we can make use of them. So moving further, let's try to solve some of the problems here. So they are asking us to find the complement of this number. Okay, f1 is equal to x dash yz plus x dash y dash z. So let's try to apply the complement here. X dash y z dash plus x dash y dash z. So when you apply the complement, so it is like x dash y z dash plus x dash y dash z, the whole complement. So using your De Morgan's theorem, what we can do, you can bring this complement inside. So when you bring that complement inside, it's x dash y z dash, the whole complement, into or and x dash y dash z, the whole complement. This again repeatedly applying the De Morgan's theorem again. So I have to bring this complement inside my brackets. So what I do, x dash the whole dash plus y dash plus z dash the whole dash. So this is my first term into, when I bring the complement inside a bracket, so that is again x dash the whole dash plus y dash the whole dash plus z dash. So this will be my second term. Now progressing through this, x dash the whole dash gives me x plus y dash plus z. So that is z dash the whole dash. And here I have a similar kind of expression that gives me x plus y plus z dash. So this is your final outcome after obtaining the complement. So this is called as f1 dash or f1 complement. So in a similar fashion, you can find out what is the complement of f2, which is x into y dash z dash plus yz. So let's start with that. So f2 complement is given by x into y dash z dash plus yz, the whole complement. So when you bring the complement inside the brackets, that will give you x complement plus, then we have y complement z complement plus yz, the whole complement. So if you repeatedly apply the De Morgan's theorem, again you will get x complement plus, so when you apply the De Morgan's theorem here, that gives me y complement the whole complement plus z complement the whole complement into y complement plus into y complement plus z complement. So that's what I have here. So if I rewrite that expression, that gives me x complement plus, so I have y complement the whole complement, which is y, plus z complement the whole complement, which is z, into y complement plus z complement. Okay, so that ultimately gives us x complement plus y plus z into y complement plus z complement. So this is your final function, which is represented as f2 complement. Okay, so in a similar fashion, you can try to apply the consensus theorem in this equation and try to simplify them. I leave it to you. If you have certain queries here, you can write it in your comments so that I can help you out. So we are at the end of the session. So thank you for your time. If you have any queries, please do email us, or you can write in the comment box so that I can answer your queries. If you like this video, please share and subscribe to our channel. I'll see you in the next video. Thank you.